Good morning. I'm going to kind of shift gears a little bit and talk about taxonomy. So today and tomorrow are going to be mostly in that classification genre. So I apologize for all the sniffling. I'm suffering pretty bad from allergies today. So I'll try to get through it with as minimal sniffing as possible. So the first person worth noting, a lot of times when you hear taxonomy, you tend to think of Linnaeus. And while he was very, very important, there was someone else that was also important that we don't always talk about, and that was Theophrastus. He's considered to be the father of botany. He lived around the 3rd century BC. Um, he was a student of Aristotle, and if you recall, Aristotle was a great Greek philosopher. He used the natural explanations, not supernatural explanations, to describe things that went on around us. So he was a noted student of Aristotle, and so and I have that misprinted here. He did not actually found the first botanical gardens in Athens. That was Aristotle. What Theophrastus did is he actually took over the gardens. So he wouldn't necessarily found the first botanical garden. He took over that garden that Aristotle had established. And so Aristotle had basically grouped things into all living things into two categories. He grouped them as plants and animals. And so what Theophrastus did is he then, and he actually developed a very decently good naming system for animals. And so Theophrastus went ahead and did the same thing only for plants. So he went ahead, and we're going to kind of go into like herbalists. These are the people that study the plants at that point. So, well, I guess I should say herbals was a book. So then the people who wrote these were called the herbalists. So, about plants. So the 4 categories that Theophrastus developed, because he didn't think that plants was a very good descriptor. He felt that there were lots of differences within that plant classification. So he went ahead and subdivided out the plants into 4 major categories: trees, shrubs, subshrubs, and herbs. So for the most part, people were not very interested. Oh, that should say shrubs. Sorry. Not shrubs. Sorry about that. For the most part, people were not very interested in plants. It wasn't until after the Dark Ages that they really saw any real use for plants other than eating, because they discovered the medicinal purposes of plants. So that kind of spurred along some more interest in plants. So then we got into that age of herbals, where there was the book written about some plants and some of those healing properties and such. And so the people, like I said, who wrote them were called the herbalists. Well, this led to the doctrine of signatures. And so basically what that said was and this is, I mean, it's kind of crazy, but if part or the whole of a plant had the shape of a human body part, that was a sign that you could use that part of the plant to treat the illness that was in that particular part. So if your plant looked like an arm, this is kind of crazy. Like if it looked like an arm or a hand, and you maybe had arthritis, you could then use that plant to treat your arthritis in your arm. If the plant looked like, if part of the plant looked like an arm, or if the whole plant looked like an arm. If it looked like a hand, then you could use it to treat anything that might be ailing your hand. So, kind of an interesting philosophy there. Um, but there was some truth to it. Some of the plants they did kind of, I'm not going to say get accurate, but kind of got lucky on that one because some of the plants that they used, actually, we still use today. Liverworts, for example, are used to treat liver disease. So the only bad thing about the naming systems at this point is that they had what was called the polynomial naming system. So basically, with the polynomial naming system, as long it could be as long as you wanted it to be. It didn't have your typical two-part name that we have today. And so what was really difficult was a lot of times people would disagree on the names, and so they would tend to make the names longer because they wanted to add their piece onto it. The other thing was, depending on where you were, you might claim that you found something completely a new, different species, and so you might have a couple of different names for the same species. It's like the mountain lion and the cougar. Depending on where you're located, it's the same animal, just goes by a different name. Now we'll get on to Linnaeus. With Linnaeus, he was around the 1700s. So his goal was to clarify and classify every single plant and animal known. So it's a pretty lofty goal, but he really, really wanted to. He liked all the naming and the classifying and wanted to write down and document every single living thing and give it a name. So he published a book called Species Plantarum in 1753, which I forgot that breath of parentheses there. What makes his classification system so significant is he was the only one to use it consistently. So he established a set of rules. He was the only one to really utilize it consistently. Um, oh, okay. Sorry, I'm looking at my notes to make sure I'm doing all of these in order. So he decided to classify plants. I mean, we're going to talk mostly about plants since this is botany. But he classified plants based on their sexual structure. So he used the term classes, which he based on the number of stamens and then the number of pistils that a plant would have. Obviously, this would only work on the angiosperms. So, or work the best, I guess I should say, with the angiosperms. This was initially this was basic. It was kind of an artificial system because it didn't necessarily reflect all those natural relationships. So anybody could identify it. In his system, some plants would fall into groups where they wouldn't really seem very much alike at all. So it was kind of hard to draw those similarities and why plants were grouped into the same grouping when they didn't appear to really have anything in common. So it wasn't a perfect system, but it was better than what they had. So, like I said, his system was a binomial nomenclature system. I'm fairly certain you've heard of this before. Binomial meaning two, nomenclature meaning name. So a two naming system. So, I mean, obviously since then we've added on more classifications. But for his, every species, every living thing had to have two parts. It had to have a genus and a species. Sometimes you'll hear that called a specific epithet. So genus is the general name or the generic name, and then the species is more specific. I like to use the example that genus is like your last name and species is like your first name. So everybody with the same last name is all related, but you're all different depending on your first name. So all of the genus plants are very closely related, but they're slightly different based on their species. So I'm sure you heard of the rules. You have to have a space in between. It's kind of a given with the two naming system. The other thing is it needs to be either italicized or underlined. It could be both. And this is more of a um, oh, nitpicking thing, but technically you should not underline the space in between the genus and the species. My words are failing me there, I'm sorry. Your genus is always capitalized, your species is lowercase. I'm sure you've seen it where it's abbreviated, and you just put the first letter of the genus, period, and then species. Typically, the period is not underlined also. So, no one's really going to say anything if you do it, but technically it's incorrect. So, and like I said, later we obviously have added on more levels like your kingdoms and your phylums and things like that. So, we'll kind of talk about those really quick. Okay. You have a classification hierarchy, and a hierarchy is just different levels, different categories. So, you have your kingdom, division, class, order, family, genus, species. In animal world, well, basically in every other world besides plants, they use phylum under kingdom. Plants use division. So plants are classified as kingdom, division, class, blah, 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 blah. So, um, for some people, it's acceptable to use phylum, but for the most part, whenever you're going to go read information on their classifications, you're going to more than likely see division, if you didn't already know that. Oftentimes, for the most part, they're going to end in phyta, like division bryophyta, lycophyta, chlorophyta, stuff like that. Then they have a class. That one doesn't usually have whatever it's called, a suffix that goes with it. Order, they tend to have ALES at the end. With the family, they tend to have the suffix ACE, AE, which if you remember back to the sunflower family, that was Asteraceae. Not entirely sure the pronunciation on that one. I sat there long enough I could figure it out. So, and then you have, and that's it. And then you have your genus and your species, which are both underlined. So, like I said, really the only main thing to note is that plants don't have a phylum; they have a division. That's the main thing I want you to walk away with on this. Okay. So there's a couple of kingdoms. Now, depending on if you're a lumper or a splitter, I can't really find any consistent classification, to be completely honest, except that the newer classifications tend to have a 6 kingdom classification. Older ones tend to have a 5 king. But in terms of like what names, there's some differences there. So it was first brought forth by R.H. Whitaker. He went ahead and divided the plants and animals out because he didn't feel like everything could be classified as a plant or an animal. So this was his 5 kingdom suggestion: Monera, Protista, Fungi, Planta, and Animalia. Since then, Monera is typically subdivided, and we now, instead of having a 5 kingdom, we have a 6 kingdom. And sometimes they're called Kingdom Monera, sometimes they're called Kingdom Archaeobacteria. Archaea, ancient, old. And then Eubacteria, Eu meaning true. So those would be your modern day bacteria. So most of your prokaryotic bacteria is going to be in Kingdom Monera. And then your, like I said, like E. coli, your cyanobacteria, like the blue-green algae, all that's going to be in the Eubacteria. But these are all, for the most part, they're all photosynthesizing and heterotrophic for the most part. So they got to take in some stuff. Yes, they can photosynthesize, but they also need to take in. Some of them are heterotrophic. I guess I should say some of them are photosynthetic, some are heterotrophic. Then we've got Kingdom Protista. These guys are now, from now on, you're basically in eukaryotic cells. You got single-celled critters here. Off the top of my head, I can't think of any that are multicellular, but that doesn't mean that there aren't. For the most part, they're single-celled. So, Kingdom Fungi, they're multicellular now, getting more advanced. They're going to be eukaryotic, like I said. They're going to have a cellulose. They're going to have a cell wall, but it's not going to be made of cellulose, unlike our plant friends. Their cell wall is going to be made of chitin. Or their cell walls, I should say. Um, they oftentimes will secrete enzymes to absorb their food, so as weird as it is, some are heterotrophic. Don't really think of them as being heterotrophic, but they can't photosynthesize, so they have to be. Then we've got kingdom Plantae. Um, Eukaryotic, multicellular, obviously can photosynthesize. Uh, they've got cellulose in their cell walls. I don't have to tell you this. We've studied this all semester, basically. And then kingdom Animalia. Um, obviously, multicellular eukaryotic organisms. For the most part, they move. I think your sponges are the only ones that don't move at all during their life cycle. But I think everything else at some point in its life cycle moves. So for the most part, kingdom Animalia is associated with movement. Obviously, they don't have cell walls, and they're all going to be heterotrophic. So you may or may not have heard of domains. This is the last thing. Domains is a level above kingdom. This was actually added on after I learned this stuff. I learned in high school about the kingdoms, but it wasn't until college that they really started to use domains. So this is actually a fairly new thing. Sometimes they're called super kingdoms, developed by Wos between 1977 and 1998. So, like I said, it's actually fairly new in terms of um, everything else. The kingdoms were developed in about 1969. So those are a little bit older, but still fairly new. But these domains are really, really new. So there are three major domains, and these three major super kingdoms. And obviously, I'm sure you're aware of this. If depending on what you have seen classification-wise in any literature, there are sub and super levels. So there is technically a super class, which would be above a class. There is also technically a subclass. And there's a super order and a suborder. So there's all these little in-betweeners between these levels. Obviously, the people that are splitters like to split these families and classes into further classifications. So, just so you know. Not everybody has one, but just be aware that they exist. So, anyway, these super kingdoms. Domain Archaea, it's going to contain the Archaeobacteria, or Kingdom Monera, whichever you're going to call it by. These are the super old or ancient bacteria that have been around for quite some time. They typically are considered the crazy bacteria. The harsh bacteria. They can survive in some pretty outrageous environments. You've got your methanophiles, which can they're going to produce the methane, so they can obviously survive in high areas of methane, which not all bacteria can. Actually, very few. The halophiles, halosalt. So there are some bacteria that can survive in extreme salty conditions like the Dead Sea for the most part. But if you get too high in concentration of salt, you're going to get that whole osmosis thing going, and the cells aren't going to be able to survive in an extreme salty condition. So obviously they would get dehydrated. So, but these halophiles are totally fine. And then you've got your thermophiles, thermal heat. So they like the super hot, like the hot springs. So sometimes they're associated with sulfur, with extreme heat, but They're like the crazy bacteria. Then you have domain bacteria that's going to house the eubacteria. These are going to be your photosynthesizing bacteria, or you're going to have some of your photosynthesizing bacteria here. Like I said, like your cyanobacteria. So the archaea and bacteria, the reason why they wanted to split those even more, like it wasn't enough to just say they're in separate kingdoms. We got to now go above. They have cell walls and they have RNAs, but they're different. They're just very, very different. The RNA sequence is very, very different. Cell wall structure is just slightly different. So they wanted to add another classification level, if you will. So they didn't need to, but they wanted to. So then we have good old Kingdom Eukarya. So, and this is going to house basically everybody else. The Protista, which sometimes we'll call Protoctista, fungi, Animalia, and Plantae. So that kind of wraps up all of the classification there. Like I said, on the thing, on your Google Classroom, you do have a test here over the entire unit at the end of the week. The only new thing is going to be tomorrow, which is a little bit more. And I will also take the time tomorrow to go over the diagrams that I left off today. They're basically just kind of visual representations of these classification systems, like the tree of life and stuff like that. So I'll take a moment and go over those with you tomorrow. So my apologies for not having those printed off for you. But if you do have any questions, just let me know. And then, like I said, next week, it's going to kind of simulate dead week for you in college. They sometimes they'll have class, but they're not, what they're teaching you isn't going to be on your final, and sometimes they don't have class at all. So that's going to just kind of simulate dead week for you because it's going to be over all 3 units. So that's going to be a lot. So I'm going to give you the whole week to study for it since it's a lot of information. So I know it's only 3 units, and I believe we had 5 units. So kind of gives you some fun there. But if you do have any questions, please don't hesitate to ask. Otherwise, have a great day.